Hey guys, it's me. Quick little intro to today's lesson. We're still in FRQ review, um, trying to get through all of the ones back to 2012 that are potential for this year. Today, I've got this spreadsheet I've been going through with all the free response questions. And let me see if I can move this thing out of the way. I'll hide that thing. Okay. So guys, today I was going to talk mostly about separable equations, and the equations that we're doing are going to have a separable equation bent to them. That's number 11. So if I filter on number 11, you can see there's been a separable equation question 2012, 13, 14. We skipped 15 for some reason. 16, 17, 18, 19. It shows up just about every year. So what I did, guys, and this document will be out, shared with all the stuff that we're doing. This is every separable equation back to 2012. They're really big point hitters. Out of the 9 possible points for a free response question, they're worth 5 to 6 points when they show up. So I just wanted to show you what they look like. If you scroll through this document, you'll see how they're worded. A lot of times, let's see, they come right out and tell you to use separation of variables. But basically, guys, they usually have like something with respect to time, or dy over dx. So they have 2 variables here, and if you notice over here, db, which is like dy, b exists on the right side. If it was just a function of time over here, it would be kind of a regular differential equation. But when you see the top differential showing up on the right side, it's separation of variables. They're usually going to say separation of variables. When they do, it's the latest, one of the later things we did in the course this year, showing separation of variables. So basically you get all of the b terms on one side, you get all of the t terms on the other, you integrate both sides. They're going to give you an initial condition that you're going to use to solve for the constant. So you can see out of the 5 points available, 3 points are to separate the variables, find the antiderivatives, find the constant of integration, and then using the initial condition. Then what they do is they separate, they get b all by itself. So that's the last 2 points. Sometimes the initial condition tells you whether there's a plus or a minus. This one doesn't look like it did that. Okay, here's 2013. Here they didn't say separation of variables. They're a little bit more vague. You've got a differential equation up here, dy over dx, and if you look on the right, you've got y and x mixed together. Separable, they're not. It's not like it's sine of x, y, so x and y are embedded in the equation. So you can separate this. So if they're looking for a particular solution, if they're looking for y equals f of x, and they give you dy over dx, that should click in your head. You're going to have to take an integral. When the derivative is a mix of x and y, that should click in your head that you're going to need separation of variables. So a particular solution means to find the antiderivative and evaluate the integration constant. If the differential equation is a mix of x and y, that should tell you separation of variables. So you can see, again, the same sort of steps, people, worth 6 points. So here, they talk about a particular solution. I look at the differential equation. It's a mix of x and y, guys. I do this one in class today, so you'll see me walk through that solution method. 2016, same sort of thing. They're asking for a particular solution. They give you an initial condition. 2017, I also walked through this one in class. This is a little trickier. They ask for g of t, and they give you an expression for dg dt. Again, guys, look, g is over here and dg's up there. I can't move just dt up here and take dg equals this times dt and integrate the right side because g's over here. So you've got to get g to the other side. So if these ones are a little tricky. It's like the first one I showed you with the db dt. Okay, if the differential, see db, if the b shows up on the right side, and in this case here, dg dt, and g shows up on the other side, you're going to have to do separation of variables to get the particular solution. You're going to have to move g to the other side. I walked through this one as well. I'm trying to remember which ones did I give for homework tonight. 2018 and 2019, 6 and 4, so they'll be showing up in a second. Okay, So I'll walk through this one in class. Okay, here they talk about the particular solution. They give you an initial condition. Okay, this is one of the homework problems. Okay, and this is the other homework problem where they talk about separation of variables. So guys, it's a heavy hitter. You're going to see it a lot. There's only 2 free response this year. This has a high probability. So these are what separation of variable problems look like. That's how you solve them. I'm going to go walk through two of the homework problems today. Two free responses today, and there's 2 more for homework. Good luck. Wednesday, we're going to do tangent line approximation.